Cycle 1, Lesson 5. In this lesson we're looking at solving polynomial equations and also inequalities. And just like everything that we're focusing on in this first cycle, we're going to do it using graphing. We're going to use Desmos. There'll be plenty of time for using equations, solving equations to get the x-intercepts and the zeros or the roots or whatever we want to call them later. But we're really focusing on the graphing for this part of the course. So let's start with a basic one, with an equation. If you take a look at this polynomial equation, let's just think about it or examine it for a second first. Think about what the degree is. Think about what the leading coefficient is, degree 3. Leading coefficient is positive 3. So that should, at this point, start giving us an idea of what the graph's going to look like. You don't have to know the exact specifics of the graph, but can you visualize the graph in any way? Is it going to look more like a straight line as far as its end behavior goes, or is it going to look more like a parabola as far as its end behavior goes? The answer is it's going to look more like a straight line because it's an odd degree function. Okay, so it's going to be like a straight line. Is it going to look like a straight line with a positive slope or a straight line with a negative slope? It's going to look like a straight line with a positive slope because it's got a positive leading coefficient. So we know the end behavior, before we do anything, we know the end behavior of this graph is going to go from quadrant 3 to quadrant 1. Now here's how we can actually use Desmos to solve it though. We want to find, to solve it, means that if we graph the related function, this is just an equation. What I've highlighted in green is an equation, but what I've written below and highlighted in yellow is the related function. So it's an equation if I set it equal to 0 or if I only have the one variable in there, that x. But now I've made it a relation and a function at the same time by swapping out the 0 when it's in standard form for this y. Now I've introduced a second variable, so now I can graph it as a function. So if you got an equation, simple thing to do, just put it in standard form if it isn't already, and then switch the 0 for a y, and then you can graph it. If all the terms aren't on one side of the equal sign, they are in this one. They were in, so it's all on one side with 0 on the other, then you need to rearrange that first. You graph it and you look for the x-intercepts. Really simple. All right, so let's go through the steps of doing that. So let's go to Desmos and we'll type it in. Y equals 3x cubed, I remember, plus x squared minus 12x minus 4. Okay? Here's our graph. Doesn't quite fit on the graph. I can always just tweak it a little bit. But let's just confirm that our prediction was right. It is going, starting in quadrant 3, bottom left, as I go from left to right, and it's going, goes up into quadrant 2, and then it comes back down, ends up in quadrant 4 for a bit, but at the end, it goes to quadrant 1, right? And it's going to keep going, staying in quadrant 1 forever as we keep moving farther to the right. I can go up as high as I want. I can play around with the axis a little bit if I want to just make it so that we can see it better. I guess I zoomed out again. I lost it when I zoomed it. But anyway, I was just trying to show that that you can really see. Well, there we go. Look at the scale. I'm already up to 20,000 on the y-axis, and it's still going higher and higher. We can go as high as we want. We're into the millions, billions. Okay? So, keeps going up in quadrant 1 forever. Starts out in quadrant 3. Anyway, that's not the part that matters for solving it. What matters is getting the x-intercepts. Negative 2, 0. So the x value of the x-intercept is one of our solutions. The y value is always going to be 0, of course, for an x-intercept. In other words, if I stick negative 2 into the equation, it's going to balance it, right? It's telling me right on this graph that negative 2x value gives me an output of 0. And if we look back at the original graph, or the original equation, it was 3x cubed plus x squared minus 12x minus 4 equals 0. Negative 2 will balance the equation, as will negative 0.3 repeating, in other words, negative 1/3, as will positive 2. So those are my 3 x-intercepts. Those are my 3 solutions. So x equals negative 2, positive 1/3, and positive 2. And that's all we have to do to solve polynomial equations for now. So the rest of this is just those numbers here, 4, 18, 9, those are homework questions. As far as inequalities go, we're going to use some really similar techniques, but I think you need to know what an inequality is before we can actually go about solving it. An inequality just means, well, let's start by looking at the equation. The inequation. 2x cubed plus x squared minus 6x minus 2 is greater than or equal to 0. So when we're solving an equation, like we did up above, let's just recap this for a second. These answers here, negative 2, 1/3, and 2, are all ones that satisfy this equation. When I put negative 2 into that equation, the answer is 0. When I put 1/3 into that equation, the answer is 0. When I put positive 2 into that equation, the answer is 0. For an inequality, we're not just looking for numbers that are going to make it equal 0. We just want any number that I can put into this inequality where my outcome will be greater than or equal to 0. So it could be 0 exactly, but maybe I'll get an output of 1 or 10 or 1,000,000. As long as it's a positive number and an outcome that's bigger than 0, then that's going to work. So there's actually infinite possible solutions for this, but there's still some that aren't. There's some values that aren't going to make an outcome of greater than 0. So I have to figure out a way to pick out the ones that are going to work and leave behind the ones that aren't going to work. Luckily, the way to do it is pretty similar. We just have to interpret it a bit differently. So we're going to find the intervals where the graph is above the x-axis. So we're still going to the graph, but we're going to look for intervals where the graph is above the x-axis, because anywhere where a graph is above the x-axis means that the y value, the output, is greater than 0. We're also going to look for where it's below the x-axis, but we're going to rule those ones out. The way we do it, we still just need to find the x-intercepts, right? Because the x-intercepts is where it crosses from above to below or below to above when we're reading a graph. So those are the key points, the x-intercepts still. In the end, we're going to write our answers on a number line. Probably. That's what we do sometimes. You don't have to always do that, but I'll do it in this case. So how do we do it? Here's our inequality. And so the first thing I'm going to do again is I'm going to change it to a function. So again, this time I swapped out the greater than or equal to 0 part for just equal to y. Right? The equation part is the same. So we still just want to see what this graph looks like. We're not going to worry about the greater than sign. We're going to graph it as an equation back in Desmos again. Y equals 2x cubed plus x squared minus 6x minus 2. Okay? Again, it's cubic. It's behaving the way we would expect. Its end behavior goes from quadrant 3 to quadrant 1 because it's got a positive leading coefficient. But now we're not just interested in the x-intercepts, although they definitely are important, but what we're interested in is where the graph is above the x-axis. Because we're looking at the y values. Any y, remember the y values are the output. So any x value that I can put into this equation, into this inequality, that gives me an output, a y value that is above the x-axis, greater than 0, is going to satisfy the inequality. So we can see that there's two sections that are above the x-axis. So between negative 1.8 and negative 0.3, we've got that little loop that you can see that's above the x-axis. So all the x values between negative 1.8 and negative 0.3 are going to satisfy this inequality. They're all going to give me positive outputs. And then anything to the right, let's get rid of those two, anything to the right of 1.67 approximately is also above the x-axis, right? The blue line is above the x-axis anywhere to the right of an x value of 1.67. So that's also what we're going to look for. All right, so let's write that down. So first of all, we can't just say x is equal to the zeros. We again have to use our greater than or less than signs. So again, let's go back to that loop I talked about. So where it was between approximately negative 1.84 and negative 0.33. I can write that as an x using my greater than or less than symbols again. Greater than negative 1.84, and it was also equal to it, because I'm going to use the or equal to sign, because here the original question also wanted to include the or equal to sign. If that was missing from the original question, then I would leave it out here as well, but since it isn't, I won't. And x has to be less than or equal to negative 0.33. So again, what we're saying is, look, negative 1.84, negative 0.33, between, let's see if I can just zoom in a bit, between these two x values, the graph is above the x-axis. I only am going to give the x values between those two, we're good. And then the other one is anywhere to the right of positive 1.66. So how do I say that? Well, I just want it to the right means greater than, and so I'll say or x is greater than or equal to, I've already lost it, 1.66. So that would be the solution for this one. Let's just recap it, read it off one more time to make sure that we're clear. X is greater than negative 1.84, greater than or equal to negative 1.84, or less than negative 0.33, or x is greater than 1.66. So it's that whole range, and there's an infinite number of points that we can find in between, in that range, and they all will give us an output that is 0 or greater. As for writing it on a number line, which is what this last little box down here at the bottom is about, we can show that graphically. This is a two-dimensional number line. So if I were to, let's just draw a number line here, and then I can put my own scale on it. So let's say I go -2, and I want it to go up as high as +4, let's say, just to pick some numbers where I can represent what I want, and then get everything in between. So -1, 0, 1, 2, 3. So I give myself a number line, and then I take these key points that I've got up above, I take these guys here, put them on the number line. So negative 1.84 is, I can't be precise, but it's going to be somewhere around here. Negative 0.33 is going to be somewhere around here. And positive 1.66 is about here. So to represent it on the number line, I put some dots on there, and these are closed circles. It's not an accident that I closed these circles in, because I want to include these actual points. And then I just draw a line connecting these two to show that I want that this is part of my solution, and then anything to the right of this one. So these are all x values. Again, we're solving it for x. So that's how we'd represent it on a number line.